Angle of elevation and depression. The angle of elevation of an object, as seen by an observer, is the angle between the horizontal and the line from the object to the observer's eye, the line of sight. So if you are the observer right here, and you're looking up, the angle that's created goes from here to here. Your line of sight to that object above creates that angle of elevation. Likewise, if the object is below the level of the observer and the angle between the horizontal and the observer's line of sight, it's called the angle of depression. So if you're the observer and you're standing above the above the horizon, looking down, your line of sight to an object below you, think of like being up on a hill and looking down in the sea at a boat or something like that. The angle of depression of the object from the observer, this is the angle that's created, and it's the angle of depression. Let's look at an example. From the top of the vertical cliff, 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? Well, the reason a triangle is drawn here is we're going to use a trig function to be able to find some missing pieces. What they're looking for here is right here. They want the distance from the base of the cliff all the way to the object over here, with what they gave us was this angle of depression. Well, the reason they drew this dotted line is to show that it's parallel with the horizontal of the horizon down here. So two parallel lines cut by a transversal creates two congruent angles. The 34 degrees here, angle of elevation, and the 34 degrees here, the angle of depression, create those two angles. So remember, two alternate interior angles are formed. Let's look at I showed it in a picture view. So if you're letting x be the distance of the object from the base of the cliff, and we've drawn our triangle, we're having to decide what trig ratio are we going to use, sine, cosine, or tangent. The tangent ratio is what we will use because of what's given. They've given us that the height from the base of the cliff is 40 meters, and the distance is what they're looking for, this distance right here. So with that, you're going to use the tangent of 34 is equal to the opposite over the adjacent. If you need to review, go back and look at your tangent ratios. But the opposite over adjacent is what we're looking at here. So going away from the picture for a minute, let's do the math. You've got the tangent of 34 is equal to 40 over x. You're looking at multiplying x on both sides in order to get rid of x. Then to calculate, make sure your calculator's in the correct mode. This number is the tangent. You can also look at a table. The tangent of 34, the x stays. That's your same x on this side of the equal sign. But this x goes away, so you're left with 40. So after you divide by the same in order to get rid of that, you're dividing, you get your x. Dividing on both sides, you'll be left with approximately 59.3 3/10 meters from the base of the cliff. So I always ask my students to look at that and see if that's reasonable. Would this be reasonable to say that this is approximately 59 meters away from the object P when at the base to the top of the cliff is 40 meters? Well, yeah, that's a reasonable amount. So you can always check your mode of your calculator. If you've calculated something that's really, really small, you probably multiplied where you were supposed to divide, vice versa. So if you have any more questions, ask your teacher.